Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today for exam P. A car is new at the beginning of a calendar year. The time in years before the car experiences its first failure is exponentially distributed with mean 2. Calculate the probability that the car experiences first failure in the last quarter of some calendar year. And here's the solution. Let us write T for the time until first failure of the car. For a year K with years indexed as K equal to 0, 1, 2, and so on, let's consider the probability that the car experiences its first failure in the last quarter of this year. Because of the memory list property of the exponential distribution, this probability is the same in every year, and we can therefore index the year as we like. So, for example, we index the years K equal to 0, 1, 2, and so on, as we just did. The probability that the car experiences its first failure in the last quarter of this year, given that it fails during, I should say really this year, is, well, the probability that T is greater than K plus 3/4, less than or equal to K plus 1. That means the last quarter of the year, given that T is between K and K plus 1. But the intersection of those two events is the event K plus T greater than or K plus 3/4 less than or equal to K plus 1. So this is the probability of that divided by probability that K is less than T less than or equal to K plus 1. And this, given that this is exponential distribution, is the survival function. Actually, it's always the survival function of K plus 3/4 minus the survival function of K plus 1 over the survival function of K minus the survival function of K plus 1. But given that this is exponential distribution with mean 2, and therefore hazard rate of 1/2, the survival function is of the form e to the minus t over 2. So in this case, we get e to the minus k plus 3/4 over 2 minus e to the minus k plus 1 over 2, the whole expression divided by e to the minus k over 2 minus e to the minus k plus 1 over 2. And then we multiply the top and the bottom by e to the k plus 1 over 2, and what we get is e to the 1/8 minus 1 over e to the 1/2 minus 1. So e to the 0.125 minus 1 over e to the 0.5 minus 1, that's approximately 0.2052476. And the probability we're looking for is the probability, actually the sum from k equal to 0 to plus infinity over all years of probabilities that t is greater than or equal to k plus 3/4 less than or equal to k plus 1, given that t is between k and k plus 1, times the probability of this failure in that year over all years. So given that the failure is in a given year, what's the probability that it happens in the last quarter, and we add it up over all years? Well, then that's a sum from k equal to 0 to plus infinity of that 0.2052476 times the probability that t is between k and k plus 1. But then we can just factor out the common factor, and what we have is the sum of probabilities of all possible outcomes. And basically, this partition of probability space that we have in those events that t is between k and k plus 1. So the sum of those probabilities is 1. Hence, the probability we're looking for is approximately equal to 0.2052476, which is answer D. Please remember, this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies and good luck on the test.